software I know is going to work. And even if I do an architectural license, it comes with a validation suite that I guarantee that my core runs the ARM software. So for Sci5, how does a customer know for sure that the software will run consistently amongst all the different Sci5 implementations?
But from the foundation perspective, one of the most important working groups is what we call the compliance working group, which is developing a official RISC-V compliance test suite that will be formally verified. And so if you can use RISC-V, you're free to use it. But if you want to call it a RISC-V and put the RISC-V label on it, you have to be a member of the foundation, and it will have to pass this compliance suite. And that is definitely, I think job number one for the foundation is to get compliance suite out in the marketplace or finalized.
So I think if you look at the investment that people have in ARM, you actually, almost everybody ends up doing a vertical software stack. And that's why you see people in Broadcom, Qualcomm. What we are trying to avoid in RISC-V is that there is this common stack. And I think this is what Ted was talking about. But other than that, I think as far as the rest of the validation is concerned, I think experience, at least at Sci5, what we are trying to say to our customers should be any standard core-based IP that they get, all the collaterals and everything else that they are used to getting, we will provide that collateral. So the experience of acquiring IP from us should be no different. And big difference we have is that we are also building a chip development capability along with our cores. So people who don't want to implement themselves, we are more than happy to actually implement their design with our cores and take responsibility for it working in actual working silicon. Not only we will back up our IP, we are willing to back it up with chips. And so people who would like to go down that, we will ensure that as well.
So I think that having a guideline from the foundation is really the way to go. To ensure that everybody follow the same rules. And also the other thing is I believe that every vendor probably have all the incentive to make sure the quality of their shipping will be compliant to the RISC-V standard. From our side, as an IP supplier, we stand by all the IP that we ship to make sure and warrant the quality of the IP, the compatibility of the IPs. From our perspective, this is actually no different from a traditional IP model. All the IP that we ship will warrant, will guarantee the compliance and also the functionality.
And I suspect many of you have seen Dave Patterson of Berkeley speak about RISC-V, and he's very proud of something, that the entire RISC-V instruction set architecture fits on one page, the so-called green card. So it's actually quite possible for an engineer to understand well the instruction set architecture of RISC-V, where that's almost impossible, for instance, on a CISC processor like the x86, and to some degree on ARM as well. The instruction set is so much simpler. It results in chips that are easier to build and easier to validate. So I think it's inherent in the architecture.
The performance testing, I think, is going to be important, and that's the foundation does need to deliver. Do you have any timeline when it's going to be delivered?
I do not. Microsemi is the chair of the compliance working group is from Microsemi, a gentleman named Stuart Hode. I could get that answer for you very shortly, but I think the goal is definitely within probably by the next workshop. RISC-V has a cadence of workshops, and so there'll be a pretty large event in this building, end of November timeframe. I would expect or hope to see an announcement around then, availability of the compliance suite.
Yeah, because it is more than just the instruction set, because you have flags and how flags are handled, interrupts and all those. There's aspects of the microarchitecture that aren't just necessarily instructions, right?
A key distinction here of RISC-V is it is not a processor. It is the ISA. And so a lot of those aspects that you've mentioned, are the responsibility of the implementer to implement. Compliance Suite is just going to cover what is actually an official ISA expectation. Testing the implementations of the cache. There are some profiles, which are how the interrupts work in a Linux system and so forth that will get tested. Hope of the RISC-V is to have the ISA, but then let people innovate with it and build the right microarchitecture for their application.
Emerson, at Andy's, how are you going to validate? I mean, that's one of the value adds you bring to the market. Anybody could download from GitHub and build their own core, but you're providing a standardized core with validation and support behind it. You think the operation of a core and how it relates to flags, how it relates to interrupts, is important to standardize, or is each micro going to be different?
Well, it's going to be, so I think that the compliance part is going to be kind of, I would say, kind of minima compliance. And then so everybody needs to be compliant with that. But on top of that, you have all kind of microarchitecture implementations. And it's hard to kind of make sure everything, piece of paper, and everybody just follow instruction. And besides that, if you do that, it actually limits the capability of the processor or the instruction set. As Ted just mentioned, that we should have some kind of compliance test in a very short time frame. We, as a vendor, we're going to make sure that all our processors are going to be compliant with the minima set. And then there's going to be other implementation, microarchitecture that everybody's going to do their own. So to make sure that they get the most out of the instruction set.
On the verification side, if I can make a comment on that. So I think on the verification side, we actually don't write RTL by hand. We are trying to write formal verification for our core generators. What it means that no matter what core this core generator generates will be formally verified. I think from the whole hardware, from whole verification point of view, that would be a very big step if we are successful in doing that. We think we have about a year and a half, 2 years to go to do that. But we can already verify parts that our core generator is doing today. Having a formal verification of your complete core generator, that will simplify the overall process of verification quite a bit. I'm talking about the verification side now.
So is that beyond the RISC V core, or is that for your whole SOC?
No, this is just for the RISC V core.
You're not going to extend that beyond that?
No. We might do that, but that's the current work we are doing is formally verify that. I mean, you can combine other verification techniques to do an SOC, but just using theorem proving to do formal verification, I just wanted to point out that would be a great scientific accomplishment if we are successful.
Just to amplify on one thing that Naveed said, as a startup company, we haven't announced when our chips are coming out, but we're well along through the design process. But I have to say, with the Chisel design tool and then the capability to create RTL, we've long been running simulations on RTL in real time. You know, the modern simulation environment, the combination of like a virtual simulation platform, the ability to run on RTL, the ability to run an FPGA, you've already run all the validation suites long before you've taped out a chip. The modern design methodology really points to this being a pretty straightforward verification process.
How you actually validate an RTL by doing that on an FPGA? We will offer a service where you could actually do that on the cloud. So you could have as many FPGAs for as long as you need to do that. So that not only reduces the cost, but also the maintainability, but also the ramp-up time, and being able to run many, many versions of that at the same time. 500 FPGAs, you could quote-unquote rent 500 FPGAs. How can we do this? It has a lot to do with how RISC V architecture work and how simple it is to do something like that. So that's another announcement we will be announcing soon. That will simplify, at least on the RISC V core side.
I just want to amplify something, take it a little bit different direction, but he mentioned these brilliant people working on the formal verification. And so another market segment for RISC V is it's basically taking over academia. So computer architecture being done all over the world, all the major universities are switching to RISC V, and it lets them come to conferences, and they're all speaking the same language now, and so they're making innovations, but they're all on the foundation of RISC V. And there's pockets of academia that are specialty is formal verification, but now they're all working on the same thing now, formally verifying. Chris Hasanovich, one of the inventors at Berkeley, I didn't like the joke, but I said, you know, Berkeley's cranking the RISC V's out, and MIT's making sure they work. MIT has a lot of world-renowned experts in formal verification, and they're all over this, so it's pretty exciting.
Well, that's it. So is Chisel an essential part of getting RISC V to market fast? Or is it more traditional RTL tools still valid?
So I'm going to just put the foundation hat on before I pass the mic quickly. But yeah, the Chisel has got nothing to do with RISC V. It